Example 5. We are to find, or first we have been asked to show that the point 2, 4 lies on the curve x cubed plus y cubed minus 9xy. Now, how do we know that 2, 4 is in this curve? Well, it should satisfy this equation. So all we have to do is just plug in 2 for the x, and right there, and then 4 for the y in here and in this one. And then the next thing we have to do is find the tangent and the normal to the curve at that point 2, 4. Okay, so how do we show that the point 2, 4 lies on the curve? Again, substitute. So just plug in the values of 2 and 4 respectively on the x and the y. Let's see, what do we have? Okay, that's 2 cubed, 4 cubed minus, remember that's x, so 9 times 2 times 4, and indeed 8 plus 64 is 72. 72 minus 72 is equal to 0. So we have shown that the point 2, 4 lies on the curve because it satisfies the equation. Okay. Next is to find the line tangent to the curve at the point 2, 4. So what do we need to do? Whenever we're looking for a tangent line, remember we need the slope and a point. We've got the point, but we don't have the slope yet of the tangent line. So what gives us the slope? First derivative, or dy by dx. So we need to extract a dy by dx or a y prime expression here by differentiating term by term, both sides with respect to x. Okay, so let's see. What's the derivative of x cubed? 3x squared. What is the derivative of y cubed? 3y squared times y prime. Minus, now we treat this as a product of x and y. So we've done this earlier. So what's the derivative of x? 1 times y multiplied by x times y prime. That's the derivative of y with respect to x. And the derivative of 0 is 0. And then collect terms or maybe we don't even have to collect y prime because all we have to do from here on is just substitute x equal to 2 and y equal to 4 and then solve for y prime. Okay, so well, I guess that's just rewriting this one into 1 times y is just y. Okay, and then I think we simplified because term by term is divisible by 3. That'll make life easier for us when we plug in the values of x and y. And there we go. So 2 squared plus what's y? 4, and you square it, multiplied by y prime, minus 3 times what's y? It's 4 right there, and then x is 2 times y prime. Then the rest is just simplifying, and then we solve for y prime. Okay, so we use 4 plus 16y prime minus 12 minus, don't forget to distribute the negative 3, 6y prime, and then solve for y prime. We got 16 minus 6 y primes, and that's that, and then you combine these two, that's negative 8, and once you put it on the right side it becomes positive 8. Divide both sides by 10 and then simplify, we get 4 over 5, and that's the slope of the tangent line. So are we ready to write our tangent line? Of course, because we've already got the slope and the point. And what do we use again? Slope point form. Okay, so there's our slope and there's our point, and slope point form says y minus y1 is equal to m times x minus x sub 1, and we just use x sub 1 and y1 and slope 4/5 and just plugging in and we're ready to go. Okay, so y minus 4 is equal to 4/5 times x minus 2, and the rest is just arithmetic, solving for y, and so on and so forth, and there we get our line tangent to the curve at the point 2, 4. So what is now the normal to the curve? Remember, the normal to the normal line is just the perpendicular to the tangent. So what is a perpendicular? What is the slope of a perpendicular line? We know that it's opposite sign and the reciprocal. Okay, so opposite sign would be negative, and then flip this, and so that's why we have 5/4 there. And then use the same point, because remember, it's occurring still at the point 2,4. So again, we use y minus y sub 1 is equal to m times x minus x sub 1. Okay, and there you go. You keep substituting and just simplifying everything until we get to the equation of the normal line. And that wraps up example 5. Okay, here are just I've pulled out just the end of the section, and we'll just choose a few of these. We're not going to do everything. We'll just pick out a few that would be interesting and then find dy by dx or y prime. Alright, so differentiate implicitly. Use implicit differentiation to find dy by dx in the following. Let me see. Suppose we want to do, let's say, how about number 3? Let's just try number 3. Okay, so in number 3, all we do is first look at the equation, and every time you differentiate y, you multiply by y prime. Okay, so here you've got 2 times xy, means that if I differentiate this, it'll be, well, let's write it down. 2xy plus y squared is equal to x plus y. So what's the derivative of 2xy? It's 2 times the derivative of xy, 1 times y, plus x times the derivative of y is y prime. Alright, so where did this come from? This is just the derivative of 2xy. Plus, what's the derivative of y squared? 2y by power rule, but then again multiply by y prime because of chain rule, is equal to, what's the derivative of x? 1. What's the derivative of y with respect to x? Y prime. And then, let's see, we've got 2y plus 2xy prime plus 2y y prime equal to 1 plus y prime, and the rest is just combining. See how we need to put y prime on the left side and 2y on the right side. So what we have now is 2xy prime plus 2y y prime minus y prime is equal to 1 minus 2y. Why is it minus 2y? Because you transpose this to the right hand side. And then what do we do next? Pull out y prime from each of these terms. So y prime as a common factor would be pulled out of 2x plus 2y minus 1 equal to 1 minus 2y. And then what's the last step? Y prime is just divide everything by this whole thing. So 1 minus 2y divided by 2x plus 2y minus 1. And there we have it. We've found y prime, or dy by dx. Number 2 is very similar to the previous problem, so you can try that, or again, this is similar to number 2. So you take the derivative of x cubed. Well, why don't we do number 4? So let's go ahead and differentiate. We've got x cubed minus xy plus y cubed equal to 1. So differentiate term by term. So 3x squared minus, put this in parentheses because what are we going to use? product rule. 1 times y plus x times y prime, because every time you differentiate y, you multiply by y prime. Alright, plus 3y squared, that's the derivative of y cubed, with respect to y, so we got to multiply by y prime, equal to, what's the derivative of 1? 0. Okay, so the rest is just combining, collecting all the y prime terms. And so we have 3x squared minus y minus xy prime plus 3y squared y prime equal to 0. And I guess we'll just leave this on this side and put these two expressions on the other side. So if I pull out y prime out of here, let me start with that one because it's positive. 3y squared minus x. Where did I get the minus x? Right there. Okay, and then it's equal to, now this would have the opposite sign because I'm going to put it on the right hand side. So y minus 3x squared. And then of course when we divide both sides by the coefficient of y prime, then we get y prime is equal to y minus 3x squared whole thing divided by 3y squared minus x. And that is now our y prime, or dy by dx. And a few more that we can work on. How about number 7 is quite simple. So number 7, we have y squared is x minus 1 over x plus 1. So differentiating both sides, we have 2y, that's the derivative of y squared, times y prime, remember, by chain rule. Now on the right hand side, there's no y term, so all we do is just apply the quotient rule. So this is, take the square of the low, we go. And then what's the derivative of the top? Is 1 times the bottom, x plus 1, minus x minus 1 times the derivative of the bottom, which is 1. And so x plus 1 minus x plus 1, right? Because you distribute the negativity, and then divide by the square of the low, we go. And that cancels, so this is equal to 2 over x plus 1 whole thing squared, and you've got a 2y prime. And so divide everything by 2, gets 2 canceled, and so y prime is now equal to what? Well, since we still have a y here on the left side, we divide both sides by y, which gives us 1 over y times the quantity x plus 1 whole thing squared. And you can do the same thing here. We could try number 6 if you like. Let's do that. Let's try number 6. In number 6, what do we do? First, chain rule of the whole thing, and then implicit differentiation on xy, and then on the right side, again, implicit differentiation. So you've got 3xy plus 7 whole thing squared is equal to 6y. So again, what do we do? Differentiate both sides. So what is the big picture on the left side? It's a squared term. So let's apply the squared term. So it's 2 times 3xy plus 7 to the first, right? I'm not going to write the first power here. But then we use chain rules. So what is the derivative of 3xy plus 7? Well, it's 3 times, so we could write it as 3x times y. We can treat it that way. So instead of 3 times xy, we can just write 3x. We can differentiate this as 3x times y. So what's the derivative of 3x? 3. And then multiplied by y. Okay. plus 3x times what's the derivative of y? Y prime. And then what's the derivative of 7? It's 0. So I'm going to write it here. That way we know what was going on. And then it's equal to 6. What's the derivative of y? Y prime. And then the rest is just solving for y prime. And that can be your exercise. So finish this problem if you want and solve for y prime. Or I guess we could do it right now. So what do we have? It's 2 times 3xy plus 7 times 3y plus 2 times 3xy plus 7 times 3xy prime, and then it's equal to 6y prime. Okay, let's see, what can we do here? Well, we can put these y prime terms on the right side. So we are left with a 6y, just combining 2 and 3, I mean multiplying together, and then 3xy plus 7, all right, is equal to, okay, so we've got again here that's 6 and 6, so we have 6y prime minus, okay, so we've got a 6xy prime, I'm just multiplying this together, times the quantity 3xy plus 7, okay, and then the rest is just, well, everything is divisible by 6, so that is canceled out, and then on here we've got y prime is now 1, pull it out, minus x times 3xy plus 7, okay, and then it's equal to y times 3xy plus 7. Okay, and then the rest is just dividing through by whatever's been multiplied to y prime. Next thing we do is divide the coefficient of y prime, and so the rest of these is going to go in the denominator. So this is now y prime now is equal to the left hand side and divided by the quantity 1 minus x times 3xy plus 7. So let's just write it, you know, in a nice way, or at least let's just look at y prime and see what's on the top. We can multiply that through. So we're going to have 3xy squared plus 7y. Then the whole thing will be divided by 1 minus, then when you distribute the x throughout here, you're going to get a minus 3x squared y minus 7x. And there you have it, folks. This is now the final answer for y prime, or dy by dx, from working out implicit differentiation on number 6. Let's move on. Alright, so how about number 9? Get x is equal to the tangent of y. So what is the derivative of x with respect to x? 1. Equal to, what is the derivative of tangent? Chain rule, we're looking at the big picture. So the outside function is tangent. So what's the derivative of tangent? Secant squared y. Times, what do we do? Y prime, always multiply. So solving for y prime is the same as multiplying both sides by, or dividing both sides by 1 over. Secant is the same as saying that what is the reciprocal of secant? You get cosine. So y prime is equal to, again, like I said, 1 over secant squared y. But what is the reciprocal of secant? It's cosine. So it's cosine squared y. So there's your y prime. Okay, here in this, in exercises 19 through 26, we'll use implicit differentiation again, but this time we'll do it twice because it's asking for the first and the second derivative. I'll just do number 1. Okay, I mean number 19. Let's do number 19. So differentiate x squared plus y squared equal to 1. So that's 2x plus 2y multiplied by y prime is equal to 0. And then everything is divisible by 2. Divide through by 2. So what do we get? X plus y prime is 0. Therefore, y prime is equal to, put x to the other side, so it's minus x. Divide both sides by y. That's why you get a y in here. So far we've gotten dy by dx. So how do we get y double prime? So y double prime is just the derivative of the right side. So what do we use? Quotient rule. Put the negative in the front and just take the derivative of x over y. So y squared. What's the derivative of the top? 1 times the bottom, y, minus, okay, x times the derivative of y is y prime. So there we have the negative of y minus x times y prime divided by y squared. But what is y prime? Then we can just substitute what y prime is. So we have that this is equal to the negative of y minus x times the negative of x over y, whole thing divided by y squared. And then the rest is just, simplifying. What do we have? So we have the negative of, okay, that's a common denominator right there. So we have y squared plus x squared over y, and then divided by y squared is the same as 1 over y squared. So that's equal to negative of y squared plus x squared, whole thing divided by y cubed. Alright, so remember that this is, we've simplified it so far, but look, what is x squared plus y squared? To begin with, x squared plus y squared is equal to 1, so we can just, might as well substitute that to be equal to 1 so that it simplifies into the negative of 1 over y cubed. And then you can try the rest of the problems here from 19 through 26 in the book, and there's some more there that you can work on. And of course, and try the ones that are in your practice or quiz me part of the My Math Lab in your account, and then keep practicing.